With example 3, we are looking at a plane, and the velocity of this plane is a continuous function, and we're given particular values. So we're given a table of values to tell us what our velocity is. We see that it's in miles per minute. So at the takeoff point, it's looking at 3 miles per minute, which is the same thing as 180 miles per hour because multiplied by 60. And then at the 1 minute mark, we're 4 miles per minute, or 240 miles per hour, and 2 minute mark, 5 miles per minute, so on and so forth. So we actually have a picture of what's going on here. So we don't have the entire function. We know that it's continuous, and we know that the function goes through those points, and we're looking to approximate the total distance which the plane traveled during its first 5 minutes of flight. Well, the data seems to point to the idea of a linear increase, like so, and if we were to drop the verticals, we can see that we're looking at the shape of a trapezoid. All right, and we know that the area of a trapezoid is 1/2 the height times the sum of the bases. All right, and the bases are the parallel sides, so one base is 3 units, the other base is 8 units. So we have 1/2 the height, which we'll get to in a second, and then we have 3 plus 8. Now the height is going to be the distance between the two bases, which is the line the perpendicular line to the bases. So we can see that's 5 units there, so our height is 5. All right, so 3 plus 8 is 11, times 5 is 55, so we're looking at 55 over 2, or 27.5. And we're looking at a total distance traveled approximately of 27.5 miles. All right, but think about this for a second. Does the plane actually guarantee to have a linear increase, like so? Or could something else be going on in between? So we're going to talk more about that shortly. But let's get a little more practice with distance traveled. All right, if we look at example number 4, all right, we have the velocity of a person on a bicycle now. All right, so we just did a plane, we did a jogger, and now we have a biker. Okay, so we see that the velocity is right here in this graph. It is a semicircle and then a triangle, and we need to find the total distance traveled by the biker during this 9-minute ride. We see that we start at 0 and we end at 9. Yeah, it doesn't touch at the origin, but it actually does. It's just the graphing software. So take a moment, pause the video, and we know that the answer is going to be the area of the region under the curve. So see if you can come up with your solution. So we know that the distance traveled is equal to the sum of the two shapes. So the first shape we have is a semicircle. All right, so here we go. There's our little semicircle. And the area of a semicircle, well, the area of a circle is pi r squared, but we want half a circle, so we're going to divide that by 2. Then we have to add to that the triangle. All right, well, the area of the triangle we see right here. All right, and the area of a triangle we know is base times height over 2. All right, so what are the values of the variables? Well, the radius, we know that's from the center to the edge of the circle, so that is a total of 3 units. So we're going to have pi times 3 squared over 2, plus, and then our triangle here, our base goes from 6 to 9, so that's a base of 3 units, and our height goes all the way up to 7. All right, so we know that we have a height of 7 units there. So 3 times 7 over 2. And that answer is fine right there. If you want to write it as 9 pi over 2 plus 21 over 2, that's fine. If you want to get the decimal approximation, I think it comes out to about 24.63 or so. We don't have units here, but that would be the total distance traveled by the biker during this 9-minute trip. For example 5, right? Okay, you hop in the car after school, and your velocity is given by this graph right here. And we have 3 questions to answer. Well, first of all, the first one's not really a question, but take a moment, look at this graph, and describe what happened on this trip. Okay, this isn't all that important, but it's just curious if you can understand what's going on. We have a velocity which is positive, and then negative, and then 0, and then positive again. All right. So if this is your velocity, pause the video again for a second and see if you can take a moment to describe what happened on this trip. Well, there's lots of things that you could say what happened. So again, I'm just going to throw one out there. You're leaving school, so the bell rings right at this point, and you are out the door right as the bell rings, and you hop into your car, and you have positive increasing velocity. So you are out of the parking lot, you are on your way home. At the 1 minute mark, you notice that you forgot your calculus homework at school. So you've got to go get it. All right? Now you can't just turn around. Before you turn around, you need to slow down. So you're slowing down during that 2nd minute, and at this point right here, you turn around because now your velocity is negative. You're going in the opposite direction. And you speed up as you're heading back to school. As you near school, you slow down, so we're getting our velocity closer and closer to 0 again. During this minute right here, the car is not moving at all, but you are. You're running to your locker to grab that calculus homework, and you get back in your car, and now you are on your way back home, and eventually you reach your home at the 10-minute mark. All right. So that's one situation. You might have something else along similar lines, but that's basically what happened on this trip, because you had positive velocity, then negative velocity, then 0 velocity, and then positive velocity again. So part B says, what's the total distance you traveled to get home? Okay, so the total distance we know is going to be the area of this triangle, and then the area of that triangle, and then the area of this trapezoid. All right, well, the first triangle has a base of 2 and a height of 2, so that first triangle is going to be half of 2 times 2. Right? And so is the second triangle. Now that second triangle is below the x-axis, okay, or below the t-axis. So we are looking at negating it, but not for total distance, because we still traveled. The car was still traveling. It was traveling in the opposite direction. So that's going to come into play when we talk about the net distance, or exactly how far away your house is from the school. But as far as total distance is concerned, we're going to include both of those triangles. And again, the area of both of those triangles is going to be 2 units. And then we also have the area of this trapezoid. Now you can find the area of the trapezoid by doing 5 plus, this is going from 6 to 8, so 5 plus 2 is 7. The height's 2. So you can take half of that 14 and get 7 in that regard. You can break that region up into a couple of triangles and a square if you prefer. Whatever works for you to come up with an area of 7. But our trapezoid there, if we again go 1/2 the height times the sum of the bases, all right, we're looking at a total of 7 for that. All right, so we have 2 plus 7, or 11. I don't know, 11 kilometers. That's how far away from school that, or that's the total distance rather that you traveled to get home. Now, what's the net distance you traveled? In other words, how far is it from your school to the house? That's what we're interested in here. Now, your school and house are not 11 kilometers apart. Okay, in fact, you were at the school at the 5-minute mark, and you were at your house at the 10-minute mark. So you can see here that your 2 buildings are 7 kilometers apart. We actually would include this 2. We would include this 2 as well, but this 2 is below the t-axis. So it's actually, even though the area is 2, we have to think of it as -2. And the 2's and the -2, they wipe each other out. And we can see that we are actually 7 kilometers apart.